everyone. Today, I'll be showcasing a project that I've been working on over the past few months. Delta V1, a 3D printed delta wing aircraft, as the name implies, designed with speed and maneuverability in mind, made out of PLA aero. The plane is 3-channel, with 2 elevons simultaneously controlling pitch and roll, and a 40mm EDF producing a maximum of 500 grams of thrust. Without any further ado, let's get into the design process. I first started by drawing a half-scale top-down diagram of the aircraft on paper. I then made a rough draft prototype of the sketch in Fusion 360 using basic methods such as extrusion, filleting, and shelling. From there, I printed a 1:2 scale model out of regular PLA that would serve as a benchmark. After splitting the CAD model into separate pieces to fit on the build plate, I went ahead and created the second prototype, this time a full-scale model out of the same filament. Now in the Bamboo Lab Slicer app, I'll be printing with PLA aero to save on weight. In addition, to provide maximum strength without being too heavy, all parts will be 2 walls with 3% gyroed infill. I decided to print the plane across 3 plates, separating the body, wings, and electronics hatch/control surfaces. In total, the entire plane, excluding the supports, weighs 206.2 grams and takes 17 hours and 25 minutes to print. Next, I will show you the assembly process of Delta V1. Unfortunately, I made the mistake of assuming that I could simply mount the EDF backwards, like a pusher prop, and that it would generate the same amount of thrust as when installed forwards. After conducting a control surface test and doing some research, I found out that I would have to entirely redesign the motor mount to achieve maximum power. This meant, however, that I would have to break apart the current version to retrieve the electronics. After morning, I quickly got back to work in Fusion 360, designing a properly facing mount for the EDF. Luckily, the revision only affected the aircraft's fuselage, and I was able to print the other parts as normal. 20 hours of CAD design, multiple failed prints, and an aerodynamically incorrect motor mount later, Delta V1 is now complete. I'm super proud of how the aircraft turned out, especially considering that this was my first big 3D printed design project. Let me take you on a quick tour of the RC plane. First, the front of the fuselage, which houses a 1300 mAh 4S battery that provides a maximum flight time of around 3 minutes. The power cell connects to a 40 amp electronic speed controller, which I chose over lighter and more compact ESCs to prevent overheating and electronic failures. The control surfaces are all hooked up to a standard 6-channel receiver, which is more than enough, as the aircraft only uses 3 channels. To keep the parts from shifting in flight, there are Velcro strips and a magnetic door to keep everything in place. Second, the wings, connected to which are 2 Metal Gear 9-gram servos, which I selected over plastic ones for their superior strength and durability. Lastly, the housing for the 40mm EDF, for which I designed a thrust tube that tapers down to 80% of the fan-swept area, directing thrust more efficiently while in the air. In total, the aircraft weighs 510 grams, giving it a thrust-to-weight ratio of 0.98 to 1, providing plenty of power. The center of gravity is about 25% back on the mean aerodynamic wing chord, considered the sweet spot for balanced flight. Well, there you have it. The initial phase of designing and building Delta V1 is finished. Stay tuned for part 2, where I will put my RC piloting skills to the test during the maiden flight. Don't forget to like and subscribe.